Hey everyone, welcome back. So you want more speed, control and flexibility from your GitHub Actions? What if you could run workflows on your own machine instead of paying for GitHub runners? In this video, we are diving into self-hosted runners and other advanced tips that can help you supercharge your CI/CD workflows. Let's start with the basics. By default, GitHub Actions runs your jobs on GitHub-hosted runners. These are temporary virtual machines in the cloud managed by GitHub. You choose the OS like Ubuntu, Windows or Mac OS, and the GitHub spins up a clean environment every time a workflow is triggered. But what if you need more control? That's where self-hosted runners come in. These are your own machines like a Linux server, a Mac OS workstation, or even a Raspberry Pi that you connect to GitHub to execute workflows. So let's see how you can set up a self-hosted runner. To add a self-hosted runner, you can go to your GitHub dashboard and here you will see this option settings. You can click on settings and here you can click on actions and inside that runners. And if you do not see these options, that means you do not have sufficient access. So you can ask your organization or your manager and they might be able to help you with this. So here you can see we do not have any self-hosted runner yet. And to add one, we have this option. So I'll click on it. So here you can see we can add like even multiple runners. And if you want to add a Mac OS runner, we can select this, a Linux or a Windows one. And with correct OS, we also need to add the correct architecture. So for example, if you have a super old Intel based Mac, then you will be selecting x64. For the newer ones or the M series ones, you will select ARM64. And similarly for Linux, if you are using x64, ARM64, you need to select this corresponding option. And a similar thing for Windows as well. So here I will be adding it to my own Mac OS machine. So I will select Mac OS and then ARM64 as I have a Intel based Mac. And over here you will see a few commands. So you can use these commands directly on your terminal and your self-hosted runner will be up and running. So let's see how we can do that. So I'll move this to one side and I'll create a new folder. I'll name the folder as self-hosted GitHub runner and I'll right click on this folder and I'll click on new terminal add folder. You can do a similar thing if you are using Windows or Linux as well. So here you will see all these commands. So I'll run one by one these commands to my terminal. So I'll do the first one. I'll paste it and I'll hit enter. The second command is the one that downloads your runner package. So I'll run this one. And this might take a few seconds depending on your internet speed. And the next command is a echo command. So I'll paste this and it should print OK. If you are getting some error, that means your download step hasn't been done properly. So you can try rerunning it. Or if you are seeing OK, that means we are all good. So next is to extract that installer. So I'll copy this and run this command as well. And it's done. And the next is to configure our GitHub Actions runner. So I'll copy the last command and I'll paste it here. Now this time it will ask for a few options. So if you want to enter the runner group name, you can enter that. I will keep it as default for now. Next is you need to name the runner. So make sure you give it a meaningful name. For example, I'll name it as Mac OS self-hosted runner and I'll click enter. The next are the labels. So you can add multiple labels. For example, I will add Mac OS self-hosted and comma, I will also add, let's say, Mac OS M4. You can add multiple and later we will see how we can use these labels to run different workflows on different self-hosted runners. So I'll click on enter now. It will ask for one more thing, to enter the name of the work folder I will keep it as default, which is _work, and I'll click on enter and it's done. So the last step is to run it, and to run it all we need to do is to run this command, that is /run.sh. So I'll run this final command and you will see that the self-hosted runner is up and it is listening for the jobs. So let's go to our GitHub Actions dashboard again, and I'll click on runners again. And here you will see your macOS self-hosted runner is up and the status is green and it is currently idle. That means no jobs are currently running on it. And you can also see these labels, that a few of which GitHub itself has added it. So this self-hosted macOS ARM64 is something that Git has added. These two labels are the ones that we have added. So now we want to run our workflow on this self-hosted runner. How we can do that? All we need to do is just copy this or any of these labels, and I'll go to my Visual Studio Code. I'll check out a new branch, and on this new branch what I will do is I will go to any of these workflows. So for example this one, and I will edit this runs on. So currently it runs on Ubuntu latest, and I'll replace it with my label and I'll save it and I'll push it. Okay, now let's again go to our GitHub dashboard, and here I'll go to pull request. I'll create a new pull request. I'll keep the name of the pull request as it is. I'll keep the description as vacant, as this is just a tutorial, and I'll click on create pull request. Okay, so now let's go to that run test job, and here as you can see the job is passed, and here when you click on setup job you will be able to see the runner name. So that means this job was ran on self-hosted macOS runner that we just added, and that's it. That's how you can run your workflows on your self-hosted runners. Now if you want to add a few more labels, you can do that just from this GitHub Actions dashboard. How? All you need to do is click on settings, click on actions runners, and click on your self-hosted runner, and here you will see this settings icon, right? So all you need to do is to click on it, and for example I want to remove this self-hosted macOS label. I can uncheck this, and after a second you can see that that label is now removed, and we can add a new label as well. So for example I want to add a new label as M4, so I will see this option as create new label M4. So I'll click on that, and this M4 label is created and this runner is tagged to that label. So now if you run your workflow with the M4 label, this self-hosted runner will pick up that and it will do the magic. Also, to secure your self-hosted runners, you should always use isolated runners for projects, run in containers or VMs. EC2 instances from Amazon are a great example, and you should keep your system patched and secure, and you can use labels to control access. So why should you use these self-hosted runners? So firstly, they are faster because you can pre-install dependencies and skip setup time, and you have full control over the environment. You can run custom tools, use specific hardware, or test on special configurations. They can be cost effective, especially for private repos or high frequency builds. GitHub doesn't charge runner minutes when you use your own hardware, which is perfect for enterprise workloads, custom environments, or even testing on edge devices. Now let's go a level deeper with some advanced tips. So you should use custom labels to target specific machines for specific jobs. For example, runner, GPU staging, etc. You can organize runners by teams or projects and apply access rules. You can use runs on, self-hosted, and Linux in your workflow to let GitHub fall back to hosted runners if no self-hosted runner is available. You can set up monitoring tools to check uptime logs and failures, restart or re-register runners if needed. Spin up VMs in AWS or GCP only when needed, and shut them down after jobs are done. Combine cost savings and flexibility. To wrap up, self-hosted runners are a powerful way to take control of your CI/CD pipelines. Whether you need speed, control, or customization, they give you what GitHub hosted runners can't. Thanks for following along in this video. Next, we have more advanced topics from GitHub Actions. And if you found this video helpful, don't forget to like, subscribe, and share it with your DevOps team. Thank you, and I'll catch you in the next one.